Hello everyone. Today we are going to discuss the fourth case of graphing exponential functions, that is reflections. So in addition to shifting, compressing and stretching a graph, we can also reflect it across the x-axis and the y-axis. But how? As we know that the general form of the exponential function that we have discussed in our previous lectures is f of x is equals to a dot or a multiplied by b raised to power x. In previous lectures we have seen how you can modify this function to understand the different transformations of this exponential function. But here we are going to discuss the reflections. So reflections are of two types. One is the reflection about x-axis and the other is the reflection about y-axis. So before that, let's consider an example so that you can understand its concept clearly. So it all depends on the sign. When you talk about the reflections, it all depends on the sign that will vary. Y is equals to 2 raised to power x. This is the one basic function with which we will play to understand the concept of reflections. So first of all, I will tell you how we can get the reflections across x-axis and how we can get the reflection across y-axis. So on one side I will write with the blue as reflection across x-axis, and on the other side we have the reflection across or about y-axis. But how you will come to know that on which axis the reflection is going to be? So for which, what we have to see, for reflection across x-axis, what we have to do, we have to multiply the function y is equals to 2 raised to power x with minus 1. So if I write here minus 1 multiplied by 2 raised to power x, what we will get is y is equals to minus 2 raised to power x. This will be the reflection across x-axis. But when we want the reflection across y-axis, what we will do, we will multiply the value of x with the minus 1. So it will be y is equals to 2 raised to power minus 1 multiplied by x, and what we will get is y is equals to 2 raised to power minus x. So this function will show the reflection across y-axis. So let's draw it and then you will understand it better that how both of these reflections differ. So in reflection across x-axis, it is clear that the values of x remain same and the values of y will be changed from positive to negative. It means if I write here x is same, there is no reflection in the value of x, or there is no inversion in the value of x from positive to negative, but the y values will become negative. While in case of reflection across y-axis, the value of x will become negative, but the value of y will remain same, that is positive. So it's easier whenever you will plot these values. You have in reflection across x-axis, you have to keep the value of x as it is and just invert the values of y, and it's opposite in the reflection across y-axis. So let's draw the table of x and y values to get more understanding related to it. So first of all, I will draw the table for the main function in which there is no reflection, that is y is equals to 2 raised to power x, so that you can understand how these reflections are impacting the function. So for y is equal to 2 raised to power x, we will have the values from, if I write here, so I will mention the original function or the parent function by the purple color on the graph as well as in the table. For the x value of minus 3, the value of y will be 0.125. For minus 2, it will be 0.25. For minus 1, it will be 0.5. For 0, it will be 1. Then for 1, it will be 2. For 2, it will be 4. And for 3, it will be 8. So this is the table of the original function. So let's plot it on the graph so that you can differentiate while plotting the reflections. So for minus 3, it's the value of y will be 0.125. So it will be somewhere here. Then for minus 2, it will be 0.25. Then here, so a bit above. Then for minus 1, it will be 0.5 here. And for 0, it will be 1. Then for 1, it will be 2. Then for 2, it will be 4. and then for 3 it will be 8. If we join them together, we will get the graph like this. So this is the graph of the parent function, that is f of x. Now we have to see the reflection. So first of all, we will see the reflection across the x-axis. For that we have to take the same values like as we have taken in the y is equals to 2 raised to power x. So the values will be from -3, x value -2, -1, 0, 1, 2, 3 and the corresponding values. And then as we have seen that here negative sign is not with the value of x. So value of x will remain same, but the value of y will be reverted as compared to the parent function. So the values will remain same, just then we will have to add the negative sign. So it will be on -3 it will be -0.12, for -2 it will be -0.2, for -1 it will be -0.5, for 0 it will be -1, for 1 it will be -2, for 2 it will be -4 and for 3 it will be -8. It means the magnitude will remain same, just the negative sign will be added and the direction will be opposite. So let's plot it on the graph. For here it is clear here that both x and y are negative, and both x and y are negative in which quadrant? X and y are negative in the third quadrant. So it is clear here that the reflection is across the x-axis. So let's plot it. For -3 we have -0.12. So it will be here, point here. Then on -2 it's -0.25. Then it will be here. Just it's the reflection of the original function in the below quadrants. It will be here. Then for -1 it will be -0.5 here. Then for 0 it will be -1 here. Then for 1 it will be -2. This point for 2 it will be -4 here, and for 3 it will be -8. If we draw it, it will be like, so it's the reflection of f of x. So this function is representing basically minus f of x. It means y is negative in this function. Now for reflection across y-axis, let's take the same points, as the value of x will not remain the same because we have to multiply with -1. So the negative will become positive. So it will be 3, 2, 1, 0, -1, -2 and -3 because we are multiplying with -1. And the value of y, what will be the impact on the value of y? So for the value of if we put the value of x equals to 3 in this function, we will get 0.125, and if we put the value of as 2, it will be 0.25. For 1 it will be 0.5, for 0 it will be 1, for -1 it will be 2, for -2 it will be 4, and for -3 it will be 8. So let's draw them. The first point is positive 3 and the y will be 0.125. So it will be, so the point will be here. Then for 2 it's 0.25, then it will be here somewhere. Then on 1 it's 0.5, then for 1 it's 0. Then for -1 it's 2, for -2 it's 4, and for -3 it's 8. So if I join them together, it will be like this. So it's exactly the reflection of the parent function. So this is basically f of -x, in which the value of x is inverted. So this is how these functions differ in terms of reflections, that how exponential function behave when we get the reflection across x-axis and the reflection across y-axis. Thank you.